Now let's work a problem out. Okay, remember C sub pk is the first thing to calculate, so that is the minimum between upper specification limit minus x bar over 3 sigma and x bar minus lower specification limit divided by 3 sigma, 3 standard deviations. And C sub p is upper specification limit minus lower specification limit divided by 6 times the standard deviation. So here we have an intensive care unit lab that has an average turnaround time. So here it is given the average turnaround time right now, x bar is 26.2 minutes with a standard deviation of 1.35 minutes. Okay. Now with an upper specification limit and lower specification limit, so we have upper specification limit is 30 minutes and lower specification limit is 20 minutes, which means the target value is in the middle, is 25 minutes. And sometimes target value is represented by the notation mu. Okay. Now the minimum value needed, okay, so you note here, under normal circumstances, which corresponds to what is called 4 sigma, for 4 sigma performance, C sub pk must be greater than or equal to 1 1/3. That is the normal performance. For superior performance, that will be like 6 sigma operations or 6 sigma performance. C sub pk must be greater than or equal to 2. So let's consider whether the lab process is capable or not. So first thing to do is to compute C sub pk, so which is minimum upper control limit minus x bar divided by 3 times the standard deviation, and then x bar minus lower specification limit divided by 3 times standard deviation. So that happens to be minimum 1.53 and 0.94, so that is equal to 0.94. Okay. And we will assume 4 sigma performance. Unless otherwise stated, this is what we have to use. We shouldn't use 2 unless it is stated to be so. So since C sub pk is not greater than or equal to 1 1/3, the process is not capable. Okay, remember, it's not about control. Okay, the process must be in control before we can start computing capability. Okay, at this point, we don't know. So going back to this table, C sub pk is less than 1 1/3, so we know process is not capable. Now we don't know whether we are here where variance is high, or whether we are here where the variance is small but only centering is the problem. So which of these 2 cells are we in? So for that we have to compute C sub p. Now C sub p is, we have the formula here at the top. So upper specification limit, so which is 30 minus 20 divided by 6 times 1.35. So that gives us 1.23. And since C sub p is less than 1 1/3, so now we know that we are here. Process is not capable and the variance is too high. The process variance is too high. Okay, since process variance is too high, that's what you need to try to reduce in the first place by making changes in the production process. So that's what's described here in B. So modifications made to the process resulted in the average turnaround time of 26.1 with standard deviation of 1.2. So we reduced standard deviation from 1.35 to 1.2, and in that process the turnaround time average also reduced by a little bit. So this may be enough to put us over the top. So let's look at the case. So after modifications, new X bar is 26.1 minutes and sigma equal to 1.2 minutes. So once again we have to compute C sub pk first. Okay, so 30 minus 26.1 divided by 3 times 1.2, then 26.1 minus 20 divided by 3 times 1.2, and that is minimum of 1.083 and 1.69. So that's equal to 1.083. Okay. Since C sub pk is less than 1 1/3, still the process is not capable. But what about C sub p? Did that change? Or is that okay? And this gives us 1.39. So since C sub p is greater than 1 1/3, the variance of the process is small enough for the process to be capable, but it is still not capable because of centering. So for the process to be capable, the X bar value, which is the average turnaround time, must be reduced and made closer to the target value of 25 minutes.